Hello, everybody. Welcome, welcome. So happy you are joining us today for another session of Innovating Out Loud. Today, we are so excited to have Sean Quinn joining us. Sean is a director of regenerative design for HOK. For those of you that don't know HOK, it's a global architecture, engineer, planning, and design firm Sean's located in hopefully sunny California.
Yeah.
I'm calling in from freezing cold tundra, Michigan, and then Joanne kind of balances us out in Seattle. Welcome, welcome, though. But for those of you who haven't joined these sessions before, it's a really great, just open conversation. You hear the title Innovating Out Loud with a tagline of saying it ugly. So it really is just kind of a conversation about particular topics. And of course, today, this one is about kind of regenerative design. But if you pull that back a little bit, it's really this thinking of regenerative principles that show up in all of our work, especially in innovation. And so the conversation today will kind of talk to us about what is regenerative design, how is it different from restorative, and just kind of getting a deeper understanding of what do people mean when they say that? The heck is regenerative? And then starting to unpack and how is it showing up in different industries, different organizations, difference of our work, and how can we all kind of bring these principles into our day to day to deliver new solutions and bring new ideas to market in ways that we would have never before, kind of without these principles as a lens to look through. But before we get into the conversation, maybe Joanne and Sean share a little bit about your connection, your background, and then Sean, I know you're going to kind of take us through a video to watch and kind of tee up the conversation to another level.
Sure. Why don't I go first, Sean, and then you can just roll right ahead.
Sounds
Uh,
great.
so almost everybody on the line probably knows me because I'm the one saying, "Come join us." Say it ugly. Joanne Garvin, I'm former Microsoft, one of the co-authors of Innovation at Microsoft, and one of the co-founders of Regenerous Labs. And Sean and I met, and he and a few other people in my Microsoft extended team introduced me to regenerative principles while I was the head of the data center of the future. And as somebody that was coming into Microsoft with 20 years of innovation behind me in technology and the built environment and in sustainability, these people walk in the door with this aim for positive, close the feedback loop mentality. And I'm like, why have I never thought of this before? It was brilliant. And it has really just changed the way I approach problem solving. Because, and I've said this on my blog a lot, once you aim for positive, the stuff that would get you to less bad or zero or sustainable doesn't necessarily get you to positive. So a lot of off the shelf opportunities disappear, forces innovation, which for me is wonderful. I know it makes some people really uncomfortable, but that's kind of the point of innovation is to be uncomfortable and figure out new things. So with that, I give you to Sean, one of the instigators of my transformation in this space.
Thanks so much, Joanne. So I'm Sean Quinn. I'm an architect by background, but over the years, I've kind of found myself living in the in-between world that exists between architecture, engineering, environmental systems development. I find myself constantly attracted to how do we solve those interdisciplinary problems that just exist because we often isolate ourselves in the way that we do work. And so over the years, I've had depending on the day of the week, the enviable or inenviable task of answering some pretty big, hairy, audacious problems that can evolve. And about 5 years ago now, I was introduced to Joanne through a couple of our partners that have been focusing on how do we move ourselves from a position of being sustainable to being regenerative, from doing less bad to creating positive nature good. And it was so exciting to meet Joanne and to then work on a major industrial style building, data centers, which we look at as being a real cause and problem within the world. But could they become something that's actually beyond the benefits that we get from Wi-Fi and fast internet that allows this conversation to happen so easily, are there other benefits that the community might get? How can we move people from a position of not in my backyard to please in my backyard, really authentically, by examining how a data center could benefit a community directly adjacent, how it could influence and inform the nature directly adjacent. Could it function like a forest? And so with that, I'll share my screen and maybe share a little bit about how we work within regenerative design today and a very fast evolving methodology. And then I'll actually explore a little bit of its roots, which go back 30 to 40 years into Australia and Tasmania through regenerative agriculture. And so you all can let me know when you see that screen.
Got it.
Awesome. So what if a development functioned like a forest, generated more energy than it consumed, cleaned rainwater, or improved air quality? What if it could capture carbon and enhance the health and well-being of people and nature? We believe it can. That's the foundation of regenerative design. As an example project of what we've been able to accomplish in the past few years, Stanford University's Center for Academic Medicine provides an example of regenerative design in practice and the methodologies that have evolved. Let's explore. So prior to development, Palo Alto, California was unspoiled coastal forest and grassland. Fast forward to today, and much of Palo Alto lies beneath impervious hardscape. The imprint of development has taken an ecological toll on Palo Alto, lowering its ecosystem performance, the bar you see on the top of the screen, and the health of nature as well as people. In seeking ways to engage nature for a new scientific workplace, the design for Stanford University's new Center for Academic Medicine began by placing an expansive surface parking lot below grade. While this reduces the site's heat island effect, it also allows for a more porous and restorative green space. The regenerative thesis for the campus is really about welcoming nature from an adjacent arboretum into the medical campus while still creating a community space of respite and rejuvenation. Through environmental modeling, solar influences inform the building shape. Each wing is sculpted to provide interior daylight while minimizing solar heat gain. The building's orientation in Palo Alto's Mediterranean climate allows 20% of that programming to be placed outdoors. If you want to build a lower embodied carbon building, build less, trust nature. And so these design moves further aid the ability for us to really enhance the ecosystem performance as building space gives way to natural environments. Open passageways draw in breezes and provide passive cooling. Areas of sun and shade allow for seasonal gardens that improve soil health and biodiversity while also creating a dynamic workplace for connection for doctors and administrators at Stanford, as well as the general public. Building occupants enjoy these unimpeded views of the outdoors, connecting them to nature and supporting personal health and well-being. A goal of biophilic design is meant to draw from the colors, patterns, and textures of the arboretum, creating a sense of discovery. As the arboretum grows into the courtyard, the restorative impact of the development will continue to increase, improving the environmental health of Palo Alto into the future. So regenerative design, quite simply put, is designing with and for nature for the benefit of people and the planet. And so that overarching topic has evolved over the years. Within the built environment, which is where I primarily work, we're looking at some of the challenges that happen as a result of development, construction, and the operations of those buildings, be they offices, airports, factories, or data centers. For the most part, what you see here issued in the text above are the briefs that come from clients or developers, higher ed institutions. These are the problems that they're asking us to solve when we build a new project for them, be it a building or a campus. Those things in red are the ones that we're really challenged by today and really sort of exhibit where the issues that we deal with as a result of climate change and environmental justice issues. In blue is a brief that Joanne wrote. when we join the project. And so everything above it, you'll kind of notice is a little bit of do less harm. How do we kind of, create something that is less bad? But the notion of trying to design value into every component moves us away from a typical position set, which is that there is a good going into a project and waste coming out. What if we were instead just to abstract that and just talk about inputs and outputs and feedback loops? Can we start looking at the problem as a greater sense of the whole? And so, regenerative design, more broadly speaking, is meant to engage the continuous and healthy relationships of the environment, building, and people, sometimes even business. When I talk about regenerative design and sort of quantifying it out for a building or a campus planning project, it's meant to enhance site's ecosystem performance beyond the native habitat. More generally, regenerative design gives new life to something that has been depleted, and it puts life at the center of every decision and action that we make. As I mentioned, the origins for regeneration really begin in the concept of permaculture. If you look at the agricultural industry across the US, around the world, predominantly we look at a sort of monospecies scaping of our landscape. Agricultural industries grow food and then kind of lay waste, slowly drawing the nutrient quality of the soil down. When we look at the practice of permaculture, the notion is to be creating an environment that is constantly reinforcing each other. Not only do the crops begin to thrive, but the exchange of resources between a diversity of crops, plants, landscapes, and as well as the animals and people that thrive in that environment continually enriches soil, continually recycles water, continually enhances air quality, carbon sequestration, as well as all the conditions that people need to thrive. So those ecosystem services are all those nature-based solutions that support life on Earth. Now, we face more difficult challenges today than we did 30, 40 years ago, but the same principles are true. But for those of you that might, still probably not on this call, but might be out there saying that I'm not too worried about climate change, well, what if I took away your wine? Right? Forest fires, just being adjacent, have laid waste to soil in Napa County, not far from where I live. And so how do we go about ways that not only are we sort of enhancing the way we grow these things, but we're actually creating an environment that thrives better? What if through regenerative viticulture, well, some of the work that we've been doing more recently, we actually begin to investigate by which the ways in which we can take the sort of native wild and bring that into vineyard grounds, but also how do the sort of activities of growing wines and grapes and other foods begin to reinforce the native wild that goes beyond, creating migratory pathways, and again, enriching hydrology and biodiversity. What if we could take that to a college campus? Shown here, our most recent campus, a regenerative campus landscape plan for Catawba College in North Carolina. The goal here is taking a historic 100-year-old campus and being able to weave the nature preserves that exist at the east and west end of campus and bring them on through. How does that not only improve ecosystem services, but also improve the academic experience? What is campus life like if you are continually living, studying, and engaging with others in a forest environment? And as we look to some of the more broader industries that have allowed Joanne and I to come together, how do we look at the problems that we see happening today in the way that we are expanding fast and impatiently in order to grow businesses and to expand the ways in which we work in a more technological future? The challenge that we see with data centers is that they begin to start to consume, upwards of 25% of the total electrical grid around the world. And so how do we make a data center that maybe looks a bit more like a vineyard than like a Costco or another warehouse building somewhere off in the distance? How does a data center begin to actually reinforce community functions? And how do we take excessive heat, excessive water use, and recirculate that with as little waste as possible back into the nature around it, allowing that nature to thrive? And the big difference here between being sort of moving ourselves towards a regenerative state is that we're actually looking for those benefits to begin to multiply on top of each other. That inertia should take hold that allows business, nature, and community to thrive.
Awesome. There's a lot. That was a lot. It was really good. I think I'm going to take it way back. So my background is not in architecture, regenerative design. So like layman's terms 101. I think we started some of this, right, with this idea of restorative and regenerative. And that came up a lot, kind of Sean, as you were talking. But back us up to that. What's the key difference from both of your perspectives on the difference between restorative and regenerative? I think maybe both for buildings, but also just more conceptual every day and unpack that point.
I'll talk before I start coughing again. Um, you have to forgive me today. I'm going to be sucking on cough drops. So I'll do the short. This is what Sean and I do. I do like the intermediate starter level regenerative, and then Sean schools us. So the biggest aha for me was in that regard of restore or regenerate. Restoration's kind of like bring it back up to where it was without a plan for how to keep going and self-sustaining systems, right? Where you're balancing inputs and outputs and not perpetual energy machine stuff, but ecosystems and feedback loops. And that's why it's something that clicked for me in innovation because network effects, feedback loops, customer feedback loops, money feedback loops. Like at the core principle pattern level, it connects with everything we teach in innovation. Um, but now, Sean, take it to the next level.
Yeah. I'll call restorative design is maybe we'll call it very simply put an apology, right? We're bringing it back to a way things were. But listen, there's still harm that was done, and while we might be back to normal, like how long can we sustain that? Regenerative is really when we start to make sure that we're actually changing behavioral patterns, right? There's an advancement that actually occurs. And so what takes hold is a mutual exchange that exists beyond that. And so in the case where we show Stanford, as I like to use it as this very practical example, taking a parking lot and creating a park is a restorative approach. The minute that that park starts to exchange with nature beyond it, when people begin to occupy it, that regeneration begins to occur. And it all depends on how far it goes, right? If you build a park, some kids might come and play in it, but if the community finds it and starts to love it, if that identity captures the culture of people there and they start to take care of it, if the nature around it allows for smaller species of plants and animals to come in and pollinators and bee species to populate wildflowers, right? You're not just building a park that you're trying to maintain, you're building a naturally thriving ecosystem that you have to manage. And so regeneration is really about creating those conditions that are conducive to life, that life can actually take hold itself. And beyond what we do, other people become contributors of it. And so that becomes not self-sustaining, but self-generating. It
Mhm.
continues to grow.
Mhm.
I want to put an example to it that data centers, right?
Yeah.
There's a lot of money being put to restore wetlands or replenish water off-site of of the data center itself. What I loved about this approach was, all right, we have to have places to drive equipment because it's an active site, but do those have to be total hardscape or can they be permeable? And if they are permeable, does that allow more of the natural water cycle to occur? But then you look at, well, we also evaporate water in data centers. We kind of did that everywhere in the world where we needed to, regardless of what that place in the world needed. But you can look at the water cycle, the small water cycle, and say, you know what, this place would benefit from evaporation, or this place would not benefit from evaporation. We needed to go down into the aquifer. So, like, it gets you to break out of these, like, here's our site.
Yeah.
We're going to do great things outside the fence line, but we're going to put hardscape and turf grass inside for maintenance. And it's like, well, you can do that, but now you have this like 300-acre scar in the middle of a community or on the edge of a community that's doing nothing good and actually is disrupting positives. So it just blew my mind.
I think one of the most
Well,
interesting pieces of feedback that we got, because there are various stakeholders that we look to when we're talking about creating some of these innovative changes, and there's behavioral change management that often needs to occur. Some groups you expect to be extraordinarily conservative. Security.
Mhm.
What's going to happen if we all of a sudden put this sort of these natural systems surrounding a data center, something that's meant to be sterile and well maintained and simple to access and use? You kind of expect that group to be potentially a little bit averse to that. Like, oh my goodness, like you're changing very dramatically the way in which we would normally just put up a big fence, clear wall, so I've got visibility of sight. For them, the notion of building up berms and dense, thick brush that might have prickers in them, that have foliage that actually screens it out, meant a more secure biobarrier. And fundamentally, you actually could create almost sort of like two layers of defense. The sort of first one, the natural layer, which the community actually gets to enjoy. That instead of seeing a big, steel box, I get to see the sort of lush landscape foliage that's representative of the nature of that place. And as a result, security's happy because you don't quite get to see where those infiltration points might otherwise, be occurring. And so the public gets to see something that they get to enjoy, and security's life is made a little bit easier. And so from the social piece of it, there are ways by which we find those mutual benefits occurring between what's going to make operations easier, but make a community happier as well.
that's great. I want to go back to, I have kind of a two-part maybe tee up for both of you.
Yeah.
Joanne, something you originally said about using this type of principles or thinking to solve problems. And I think on one hand, it's really easy to see how these principles and this thinking apply one to one when you're planning a college campus or you're building a large data structure or even a large building because you are physically taking up space in nature, right, and putting something on top of it. But I really want to connect a couple dots of how does that thinking apply to an automobile? How does it apply to a medical device? How does it apply? And Joanne, you said the what came to my mind is the like net zero and net positive. I think about net zero as like restorative. You're just doing, less harm. And perhaps the target's actually net positive, where vehicles are actually replenishing the environment, just not putting bad stuff into it. And so maybe I'm drawing some parallels there. So my two-part kind of question to round out this jumble of thoughts is, are there common principles within, regenerative design or innovation? What are those and how might those start applying across other industries and applications and problems, etc.?
Yeah, it's great. I can begin with maybe some of those life's principles. We
Yeah.
often look to biomimicry, a long-term partnership with Biomimicry 3.8, in talking about the ways in which we evolve to survive, adapt to changing conditions, to be locally attuned and responsive, to use life-friendly chemistry, to be resource efficient, and to integrate development with growth. It's probably worth defining biomimicry. It's the study of biology to advance this to advance solutions to human-driven challenges. And so, what are the ways by which we look at systems thinking within nature? And so, if it's industrial design, designing an automobile or an eVTOL, what can we learn about drag forces that exists within different aquatic species that might inform better aerodynamics? How can I look at a humpback whale fin and how it makes giant creatures that make acrobatic turns to
Hmm.
reduce structural forces on a skyscraper?
Yeah.
How do we look at the way natural systems begin to interact with each other and trying to think about how to plan a city? And so there are actually really great ways by which we look to nature. One part to kind of abstract the way that we think, to quiet our clever minds. We've all been trained in a singular way of thinking through our sort of deep levels of expertise. open our eyes up to that often can, at the very least, abstract it and allow for blue sky thinking. And at best, it actually leads us to look to ways by which nature has evolved to challenges that have been thrown at it for millennium, and to which the solution sets are pretty broad and varied.
Mm.
I'll give you, it's not cars, it's bikes. But Rita McGrath told us about this African bike service where it's e-bikes, which is a great form of transportation. It's affordable and reliable if you can afford the battery and you can recharge the battery. This group looked at the ecosystem of people and places that they're in, and they said, okay, people can afford the bike, they can't afford the battery, and they don't have regular electricity supply to recharge the batteries. So if we treat it more like a bird and a flower, right? Like abstract that system approach of food and foraging, people can have their bike and they can go from battery bank to battery bank and just swap the battery. Now they don't have that upfront cost of owning the battery. They have a reliable form of transportation, which means they can work, which means they can get to the doctors that may not be right next door, right? Like you're thinking about rural areas and dirt roads and less infrastructure for mass transit and things of that nature.
Mhm.
So you can really take these principles and as I love, Sean, that you brought up the abstract. You can apply them very literally. How does a fish move through water? We're going to design a train to do that. Or you can abstract it to the systems and the functional, the underlying function that's happening. And that's the key for me was I'm not studying the form as much as I'm studying the function of different things.
Yep.
Mm. That's great. Our little window just popped up, and I always forget to mention this at the start, but we will be doing a Q&A at about a quarter to. So please, as different questions and thoughts come up, drop those in the Q&A box below at the bottom of your screen, and we'll be happy to kind of dive into those. You guys, so that was kind of maybe one principle is modeling it after nature. Is that kind of the regenerative as a whole, or are there other principles that complement that one?
I mean, the most central tenet to regenerative design is putting life at the center of every action
Mm,
that we make. So, what are the ways by which nature functions that we can look to it? Of the sort of six I listed out there, the one that becomes really interesting, and I'm seeing some of the questions pop up, evolving to survive. Right? There's a notion that there are a lot of regular challenges that we face every day, and they're the sort of outliers, major
mm.
storm events, conflicts that can really put pressure. Regenerative is really trying is meant to begin to identify what are the mutualisms that can occur between different groups as well as different priorities, and that can be a business to
Well,
business, and it can
let's
also
stop for a
oh,
second and
oh
actually
yeah,
define mutualisms because this
sure,
is the difference between win-win
go,
and
yeah,
regenerative mutual benefit.
yep.
Go for it.
Oh, you want me to do it? So,
Yeah.
mutualisms, right? Very simply put, it's when both parties are benefiting from any one action. And so, any entity has a series of, we'll kind of call it wants and needs. And the key goal is to identify what every different entity or body has to have and what are the ones that they want. And if we're providing one, if one entity is providing a service, how is it going to allow for some other mutual benefits to occur? And so if you are creating a new building, right, there's obviously job creation, but that's the very simple one, right? What are the other ways by which a community space might become resilient to extreme snowstorm events that allows for a public gathering space in case of a blackout, right? What are the ways by which one group might be able to benefit another? You want to pick up on that, Joanne? Yeah.
Yeah, because I think we all in like we all naturally get that, but that still leads a lot of people to think win-win.
Hmm.
And there's three other pieces of it, which is you're exchanging something different. So party A is giving something that party B needs that doesn't have, and party B is giving something different back to party A, right? And then if you do a matrix, then there's all kinds of A's, B's to Z's. Then there's the requirement that the things being traded are easy to provide. You don't want to put stress into the system from the start by making people or entities or systems provide things they have to work really hard to do. So you look for those easy to provide connection points. And then the fourth and
Joanne, to
final,
piggyback on that, just to connect it really quick for you to the third, Sean, you said needs and wants. I think like to put that into practice, connecting what you
Yeah.
said and what Joanne just said, is for every thing, person, individual within your ecosystem, and this is what we practice, right, in regenerate practice in Regenerate Labs, is you look at needs, wants, and offers.
yeah,
Like
Thank you.
what can not only what does each entity in my ecosystem need? What do they want? But what can they offer to other entities within the ecosystem, which is where you get that almost, cascading impact across everything. So I want to make that really
yeah.
quick, Joe. I didn't mean to cut you off.
No, that's great. No, it's needs, wants, and offers. And then the fourth and final one is something we all get wrong all the time. Engineers, software developers, building managers, data center providers change over time. It's so critical to not just think from zero to something, but you got to think something to scale that's going to live for however it's going long it's going to exist. And in that existence, it can't be static. Nothing is static in the world. Not even rock is
Mhm.
static. So we have this weird tendency to make things static, and it causes such negative ripples in all the systems.
Yeah, and say where that can also be really wasteful is if there's a singular objective done to any individual strategy, right? The more sort of multiple benefits or multi-objective thinking that we can bring into an action, the better off things are, right? Um, when you start thinking about what is the landscape going to do, it is not just going to look beautiful, right? It should provide a place for people to enjoy. It should provide a place that's going to manage stormwater. If you think about the creation of a new business, how does it reflect the identity of the place where it's living in? How does it reflect the brand of a company? All of those essences are really important for us to convey in design as well as in the operations of a building in the same way, in the way we actually operate as a business or as a community.
This that was where that design value into every component came from in the
Yeah.
design brief. It was like, all right, we Microsoft already had a plant trees mandate, right? Like if we're going to go in and put a data center up, we're going to restore some forests or at least stands of trees, because there is a difference. But we looked at it and we said, okay, uh, trees are great. We love trees. But can they also be screening? Can they also be security? Could they also be food? Right? Like if we're in edge communities, because we all know the geopolitics, these things are not landing on Mercer Island off of Seattle, right? Like they're out where kids like me grew up. Well, if we have food distribution issues, or even if there's just humans there, humans need food. If we're going to plant acres of trees and perimeters, why not make it a foraging forest? Why does the tree have to just be an evergreen or something like that? So it's asking those questions of needs, wants, and offers that lead you to go, oh, I want a tree, but my neighbor needs an apple. So
Yeah.
I'm going to plant an apple tree.
I
Mhm.
think what becomes really important, like the next step of that, then is what are the circular flows that evolve out of that, right? This is not a singular exchange that occurs. It has become sort of an actual means by which the sort of a project or a community begins to thrive, right? We all begin to make that our regular practice.
Mhm.
Yeah.
Mhm. Great. So there's there's been a phrase we've said ecosystem, right? Which I think conceptually we all understand an ecosystem, right? It's a collection of pieces and puzzles and people and everything that all need to work together to make something bigger happen. How do you how do you go about kind of defining an ecosystem? Because you could, I could see very quickly, it's like, where do you draw that line in terms of what do you include as part of the ecosystem? Or if you kept going, well, because essentially everything connects to everything at some point, and before you know, your ecosystem would be the sun, stars, moons, and all the ground we walk on. So how do you think about that and what are some practical ways? I think it'd be really great both within the kind of the agriculture engineering in applications, but also in a manufacturing context or something and kind of talk about how you use these principles and this thinking across both.
Yeah,
Yeah.
I'll begin with the literal sense of ecosystem here, right? How are we doing place-based design? So a solution that we come up with within California shouldn't be the same one that we're doing in Michigan or in Hong Kong or in Dubai, right? The way in which we approach it might be a very similar methodology, but defining the ecosystem is really understanding the full mixture of climate and habitat and the flora and fauna that exists within a place. Drawing the boundaries of that is sometimes very hard because, to be honest, ecosystems can change and vary from a small scale to a much larger scale, and those changes can be vast or very narrow. Ecotones become the sort of those places where ecosystems begins to overlap, and what's also that's where exchange and diversity thrives the most. And so every place we work with ecologists to really study what truly characterizes the natural environments within those spaces. That tells us a lot about where we can derive from the sort of the natural definitions. There's the ecosystem of culture to now move us to the metaphor of it, right? What is the history of people in that space, right? How are they working there today? Going back generations, going back to native people that may have become before us, that we ought to be giving recognition and acknowledgement to. So it's thinking through another lens of time towards it. Maybe Joanne, I'll pass the ball to you to thinking about the ecosystem of thinking that can not
Yeah.
always be natural. It can be diverse ways of,
And Joanne, I'm going to throw in I'm going to throw in something else for you to pile on because connecting it
Okay.
back to innovation just in general.
yeah,
And right, a lot of us are, I'm assuming, are familiar with the concept of human-centered design and thinking about the humans within the ecosystem, connecting that. I think regenerative takes that a step further, where you're not just thinking about people, and this is in a general kind of innovation capacity. You're thinking about the people and bringing in those human-centered design elements, but there's also other assets within the ecosystem that need to be considered to make it regenerative. So clean that up for me. Help me kind of unblur those lines or make those connection points.
Well, anybody that's read the book knows my core principle of innovation is diverge, converge, synthesize. And diverge means whatever. If you're designing a business, a building, a widget, step back from it and look really, really wide and try to find as many angles on that thing as you can. But I took that when I coupled that principle with regenerative, what works for me to not have to starkly define what an ecosystem is and where my boundary boxes are is in human-centered design, life-centered design, any centered anything, it implicitly directs you to design from the center out.
Hmm.
And the divergent way to do it is to go from the outside in. And so, what we did with the data center of the future, what we do in the lab is we back up as far as we can go. That's like our brains are capable of processing in as a group. And with the data center, it was like, okay, here's the geopolitics of the world. Here's the national rules of the world at the nation level. Here's the states. Here's the regions. Here's the town. Here's the land. Here's the building, right? Like we went way, way wide. And what it allowed us to do is all of those needs, wants, offers. And then we could put a lens to it and say, what do we have access to? Who could we actually work with at these different layers? How could we impact them? Could we give something to the geopolitical layer of the universe? Probably not at the level we were working, right? So by going super wide as we could go, and then doing the exercise, we felt like we had done the very best to get the full picture before we started to converge. And that can work like if we think about it in manufacturing in a business sense, if you're just looking about like, remember back in the day when Nike's like, hey, I don't have any carbon emissions because all of their manufacturing was third-party factories. Well, that was them looking from the center out and they stopped at their own walls. We all called BS on them and now they do outside in and they're like, okay, our demand creates demand on these second tier suppliers, and their demand creates demand on these places in the world, and that demand creates jobs, but it also creates safety issues, et cetera, et cetera, et cetera. So if you start from outside in, you're going to capture that on the first pass. It's much easier. We always get to the center. It's like the Tootsie Pop, right? You're always going to get to the center. But if you start at the center and work out more times than not, you never get past that first wall, maybe that second wall.
This could be a really dumb question. I'm going to say it anyways, say it ugly.
Yeah.
Could something be considered um, innovated or designed regeneratively if it doesn't ultimately positively impact the environment and it only impacted the people? So, I mean, I think again, we're like back to the space, right? Manufacturing plants. It's really easy to like see the translation, but like what if I was responsible in my job for creating a better pen? I probably don't have, the foresight, the responsibility to think about the factory footprint itself. It's just about a better pen, to go back to kind of the famous example. Like how do I take that into something this scale? And think about it. And if it all the mutualisms and the ecosystem of this pen, but it doesn't reach the environment level, kind of where does that thinking?
So building off of Joanne's discussion there of Nike and the sort of creation of any product, right? How can we be regenerative in that product design? I think the first big step is taking that attitude, right? Put life at the center of it, think from the outside in. And so that's the first big shift because we're often just thinking about how do I design the product for my possible client or for whoever's purchasing this. So the biggest shift is in that attitude change. The next change, very similar to what any business needs to do, that pen that you're holding there, right? How are we designing that so that you, the individual, can use that in the best way possible?
Mhm.
Where are all the pieces of that pen coming from? Where's the ink? Where's the casing? Where are the caps? How are those being made? Are they being made, extracted from fossil fuels, turned into plastic that are fitting into it? Most likely. So, what are the other sources that we can use to do that? If we start looking at any type of more bioengineered plastic replacement, we're in a good first step. Then who's actually manufacturing it? How are they being treated? Right. So the ultimate regenerative pen that's being created is one in which it becomes really clear. You get a longevity built into that product. It's not something that is disposable and easily replaced. The people that are building that are benefiting from the jobs and are being fairly treated for creating that product. And all the lenses of the chemistry that's going into that product are coming from other life friendly processes.
And I'll give you one from the data center of the future. From the center out, um, everybody recognized that steel and concrete are high carbon materials. They have a big impact, negative impact in the world. It's a significant portion of the world's emissions. So they naturally started thinking about timber structures. And Microsoft has, and I think others have since gone on and built timber-based data centers. We went from the outside in and we said, well, if concrete and steel come into our network, our ecosystem. Why are they coming into the ecosystem? Oh, because of walls and foundations. Do we need walls and foundations? Oh, why do we need walls and foundation? Literally ask the question, the dumb question. Why do we have walls on the data center? And everybody's like, keep the weather out. And I'm like, why? Like, you can put a rack inside a box and it keeps the weather out of, like, who's the roof for? Like, why are we holding a roof up? And that led us to a simple statement of no dumb walls. And it was like once we had that view of our data center, we're like, well, what the heck does a data center look like if it has no dumb walls? We ended up still building some structures with timber, just like the mainstream center out did, but it is a fraction of the amount. It is a totally different shape, different purpose. And so we never would have gotten there had we started just with how do we reduce concrete and steel? Go to timber, but we're still building giant places with timber.
And so then our next steps in that, and the way we thought about the site design, how does the site become the wall? Right? How does it help induce airflow that actually helps concentrate where the fans are going to need to be to blow that airflow through? And where those timber beams are coming in, how do we make them as modular as possible? So should it so happen that the data center of the future is all of a sudden the data center of the past in 50 years and it needs to come down? Well, rammed earth walls, dust to dust. Yes, some
Yeah.
energy went into putting them there, but that is a completely reusable material. And an appropriately modularly sized timber beam could be taken apart, disassembled rather than deconstructed, and placed somewhere else.
Yeah.
And so I think it's that notion of really trying to make sure that you are thinking about the extended life of what you are building and noting that nothing's permanent, everything's evolving, growing, and changing.
Awesome. We have two great questions that are starting to roll in. So both of these kind of pick up, dovetail pretty great into what we were just discussing. Ask the first one, see if any different answers come to your mind. We may have just answered this one in the past discussion, but then I will go through the second one. So question number one is, how do you think about scale and replication with this type of design that feels very specific to place and environment? And we kind of just talked about that. But if that kind of specific question sparks any other thoughts for you, I'll open it up.
The
It
other,
did
yeah,
because
They're like,
can I
yes,
share
go
yes,
the
for
let's
it.
guiding
keep
Go.
talking about
principle?
this.
Um, so obviously data centers are showing up everywhere, and I've got a group of people in the room saying it's got to be place specific, and I have a group of engineers manufacturing data center stuff going, it's got to be globally applicable. So we made it a design principle. We're like, we need to design for global applicability, local desirability, and not, it didn't take us long to figure out, oh, we can do that through a manufactured, modular, configure and install process versus design and build on site process. And then it had all kinds of positive business implications about safety and circularity and global supply chain management and all of these other pros and benefits to the business, not just the community. But it was recognizing that it can't be snowflakes that we deliver, snowflake data centers that we deliver custom built every time. That's just not going to happen. But there are things that we can do. We just stripped the irreducibly, I we made it as simple as we could make it, and then everything else was the last mile. That's how I'll put it.
Yeah. I'll add into that I think what's so important is in trying to design to then scale and replication is beginning with pilots. And pilots often aren't like extra large mega scale, right? We often start small. We want to see what's already available that doesn't need to be reinvented and what does need to be rethought through and reinvented and challenged. by then building small, testing it,
Yeah.
proving its value, observing it. We then can look at the ways we've been doing that at a much broader scale. So I would take a building that's 50,000 square feet and now do it on a building that's a 500,000 square feet. And so I think working at that, it revolves back to Joanne's point about modularity, right? Once you've really gotten that module fully dialed in, you sometimes lose the essence of scale as being a possible divider in that. And so when we were working on the data center project, right, it began with modules of timber beams to creating a canopy to creating a series of canopies. The site works that need to have happen there. How do they become as replicable across a broader site that then makes you have to think a little bit more dynamically about the ins and outs of both infrastructure operations, but also of ecological systems that are flowing through it. But they begin to allow, once you've kind of dialed in the smaller scale, you can begin thinking outwards again.
And it
And I'll
points, just one additional, it points to one of my favorite principles that came out in the book that we named in the book. You have to innovate upstream to succeed downstream. So many of these decisions will have implications on the process that you use to design and build things or produce things in the world, or how you price them or who you buy your materials from. So it really takes you back up the value stream, and you start recreating things from the ground up, or however you want to say it.
Mhm. And that's maybe the connection point, because a lot of the
Oh,
innovation projects that I work on aren't specific about a place or a building or an infrastructure. And so if this type of thinking or perspective is brand new to you, it's like it's take a working session with your team on any problem you're solving in any capacity and lay over some of these principles and just sit with that for an hour and hear, like, ask, how would nature solve this problem? Are there, to some of those earlier conversations, right? Designing aerodynamics based on birds, right? Whatever it may be, ask some of those questions, map out your ecosystem, talk about needs, wants, and offers, and just kind of like that thinking and those principles that are part of regenerative design apply again to just the most basic problem solving you can go through. And the more you practice it and the more you start asking those questions, the more it almost becomes second nature. It's like with Joanne and Sean, this type of thinking is ingrained in how they view the world. And so it's really easy to just start talking about it as if that's the way we all live and breathe, which is why you guys are such phenomenal thinkers in the world. But that's right, kind of just connecting it back to the most basic. It's bringing some of these principles into your general sticky noting, whiteboarding sessions, whether it be a toothbrush, a pen, right, or a data center. And it's pretty remarkable how it can take you just to completely different conversations and ideas and thoughts and just pull out different things. Okay. A second question that's really interesting. So nature, notoriously, takes a long time to evolve and change, but many of us are facing shorter term business pressures. Any tips for navigating that tension? And then I'll go back
Yeah.
to short-term business pressures, but also just hierarchy that exists in businesses, right? Coming back, like the person that's designing this, even though they may have thoughts about which manufacturer the resin's coming from for the plastic cap, what's their level of influence? So talk about kind of business influence structure and short-term pressures and how to navigate that.
what do you think, Sean?
Well, one thing I'll start with, in the same way that nature takes a long time to evolve and change,
Go to
so
business.
too does construction, so too does business, right? So I hear you on the tension. I think I most commonly say when people ask me what's the biggest opposition to us in instituting this change, most people presume it's going to be cost, and I actually don't think that's it. I think it's patience. It's not necessarily even time.
People,
It's
it's
just that
always
we
people.
are
Hmm.
inherently impatient. It's sort of, I know what I want, I know what our target is, let's go. And that moment of, whoa, let's pause and plan and change is an immediate friction, right? You just told me to hold back, but I'm ready to go.
Yeah.
And where I think what becomes relevant to this, the importance of that planning process is there a way that if you actually pause for a short period of time, you're going to be able to get to the ultimate solution that a whole industry needs to move before everybody else. And
Still
can you,
tortoise
by
and the hare.
doing
That
yeah, what's that?
still holds. The tortoise and the hare.
Yeah, right. It's we have to sort of pause on the moment because if you in the case of doing anything large scale, permits, availability of products, materials, resources. The biggest thing opposing data center expansion right now is there is not enough energy and water in the world to supply the demand for which data centers need. So if you're not thinking differently about it, the data center industry is going to reach a plateau because they're just going to be out of the things that they need to build and operate what they're trying to do. So the team that comes up with that solution first, whew, they're going to win the race. And so, while that does take time, and there is no doubt tension to that, finding the value point and saying speed to market, like that is way better than the 10% incremental cost of that solution. Because if you get there a year and a half before, 10% of a building cost, it's nothing compared to the operations of a data center. It's probably a magnitude of 10 to 1. So that 10% all of a sudden becomes 0.01. That's nothing.
I will add, I don't care if it's a pen or a data center or a business model. If you do the work to go wide and paint a really big, ambitious, what the future is you actually want, you can always bring that back down to what's possible today and start laying those stepping stones down, and all the while talking about the big, beautiful future, but celebrating the first step, the second step, the third step. I've been talking about the regenerative data center of the future now for 4 years. Brad Smith came out last week, or maybe this week, with a laundry list of community first AI data centers. Now, I see the trail of seeds and breadcrumbs. Everybody that worked on that project at Microsoft laid down and had conversations, and it didn't happen overnight. It had to happen in stepping stones, timber framing first, and this and that and the other. And it's still not 100% of the vision we laid out, but the vision exists. And once people see something, they can figure out how to get there. In my career history, and Dean's actually, we say this in the book, about 5 to 7 years is kind of what it takes, depending on the complexity of what you're trying to change. And then if it's really big change, could take a generation.
So we'll end with patience and storytelling.
Yes,
Yes.
Storytelling's big.
very
Well,
cool.
this was extremely insightful. I know Joanna and Sean absolutely love this topic, and we do too at Regenerous Lab. So if you have additional questions, thoughts, want to share perspective, we are always open to a conversation. And again, just thank you all so much for joining us today. And Sean and Joanne, thank you for spending an hour and sharing all your perspective and insights. It's always so fascinating. This is one of the things I love about my job is just learning and hearing and then sleeping and like, oh yeah, and seeing it happen. So thank you so much.
Thanks,
Thanks so much
Sean.
for
Thanks,
having us.
Taryn.
All right.
And
Have a
thanks,
good afternoon,
everybody.
everybody.